Well, hello, Assalamualaikum warahmatullahi wabarakatuh. Hello guys, today I will present to you some materials related to statistical analysis and fair measurement. Are you ready for today's discussion? Great, let's start our discussion today. So, the first material that we discuss today is about correlation study. Do you ever heard about correlation study? Great! So, correlation study is a type of non-experimental research that design and investigate the relationship between two or more variables. The primary goal of this study is to determine if and how variables are statistically associated, rather than establishing a cause and effect from that relationship. The common correlation coefficient that used in correlation study is person's product moment correlation. And then, what it examines? Great. It looks for pattern and relationship between variables as they naturally occur in the world. Usually, researchers measure variables without manipulating or controlling them. And then, let's move to the types of correlation or relationship. The first one is positive correlation. As one variable increases, the other variable also tend to increase. For example, more hours studied, higher exam of the student scores. And the second one is negative correlation. As one variable increases, the other variable tends to decrease. For example, spending more hours on social media result in a lower attention student in the classroom. And for the last type is zero, or we know that with no correlation. There is no consistent relationship between the variables. For example, it's about shoe size and the intelligence of the student. And then we talk about correlation coefficient. A correlation coefficient quantifies the strength and direction of correlation. Typically, it denoted by R for person product moment. And this value range is start from -1 until +1. For the positive one, it means that the correlation is perfect positive correlation. And for the negative one, it means that is perfect negative correlation. And if it is zero, it means that there is no correlation. If the value closer to +1 or -1, it indicates it has stronger relationship. And the next one, when we use correlational studies, of course, while we investigating non-causal relationship, and then ethical or practical limitation, and then while we want to explore potential causal relationship, and then testing new measurement tools, or understanding real-world phenomena. And then, what is the method of data collection? The first one, we can use survey or questionnaire. It means that we gathering self-report data from sample or participant. And the next one is naturalistic observation. Observing and recording behaviors in their natural setting without interference. And the last one is archival research, analyzing existing data or record. This is the most crucial point to remember about correlational studies. Just because two variables are related, it doesn't mean one causes the other. The second material that will we discuss today is about t-test. Anyone of you know about t-test? Great! So, a t-test is used to compare the means of two groups to determine whether the difference is statistically significant. There are some common types of t-tests. The first one is independent sample t-test. It compares two different groups. And the second one is one sample t-test. It compares the mean of a single group to unknown values. And the third one is paired sample t-test. It compares the same group score at two different times. And then there are also some steps to perform a t-test. The first step is we have to state the hypothesis. And then we choose significant level. And the third one, we calculate the t-statistic. And then we determine the critical t-value. And then we compare t-statistic with crucial value. And for the last, we calculate the p-value. And then when we use the t-test, of course, when it has small sample or unknown population variance, it means that the samples is under 30 sample. For example of this t-test is a teacher want to know whether a game-based vocabulary teaching method improves students' vocabulary knowledge. The teacher compares students' vocabulary test scores before and after the intervention. A pair sample test would show whether the post-test mean is significantly higher than the pre-test mean. And the third material is analysis of variance, or we know that with ANOVA. ANOVA is used to determine whether there are significant mean differences among three or more groups. If the overall test is significant, researchers conduct post hoc tests to identify which group differ. And there are also some types of the ANOVA. The first one is one-way ANOVA. It compares means across one independent variable or factor with three or more levels or group. For example, comparing test scores of students taught by three different teaching methods. And the second type is two-way ANOVA. It examines the effect of two independent variables or factor on a dependent variable. It can test for interaction effect, whether the effect of one factor depends on the other. For example, we compare crop yield based on fertilizer type, factor A, and The irrigation level means factor B. And the third one is repeated measures, ANOVA. It used when the same subjects are measured multiple times under different conditions. And for the last type is MANOVA or multivariate ANOVA. It extends ANOVA to cases with multiple dependent variables. The example in ELT is a lecturer compares the effectiveness of three speaking teaching techniques. For example, role play, debate, or presentation. After applying this method, ANOVA is used to test whether students' speaking performance differ significantly across three groups. And then when we use ANOVA, of course, while we comparing three or more groups. For example, it's about different treatment or teaching method. And then while we testing interaction effect, it's two-way ANOVA. And then repeated measurement, or we use repeated measures ANOVA. Now we move to the test bias. Anyone of you know about T bias? Great. Test bias occurs when a test systematically advantages or disadvantages in certain group, not because of the ability being measured, but due to irrelevant factors such as the culture and the gender or socio-economic background. For example, a listening comprehension test uses culturally specific American idiom or dialect unfamiliar to students' different culture background. The student may fail not because of poor listening skills, but due to lack of cultural knowledge. This is the example of cultural bias. And then what about differential item functioning, or we know that with DIF? It is an advanced statistical method for detecting item level bias. An item shows DIF if students from different groups, for example, male and female, with the same underlying ability have different probabilities of answering it correctly. For example, a grammar test includes a question about football, which may be more familiar to male students. If analysis shows that male are more likely to answer correctly than female with equivalent grammar ability, the item demonstrates DIF. It functions differently for the two groups. And then there are also methods to detect DIF. I will mention some to you. The first one is Mantel-Haenszel or MH test. It compares how different groups perform on item after matching on ability level. And then interpretation. If odds ratios differ significantly, DIF is present. And the second method is logistic regression DIF analysis. Usually, it predicts items' response based on the ability, group membership, and also the interaction. And the third one is item response theory or IRT approaches. And for the last one is large T-square test for IRT model. And then how to address DIF and test bias? Of course, the first one, we have to revise and remove bias item, reword culturally specific language, and then ensure examples are universally understandable. And the second one, use DIF analysis in test development. So, maybe we can conduct DIF checks during pilot testing. And the third one, we can apply statistical adjustment. If removing item isn't feasible, we can use equating methods to adjust the score. And the last one, ensure fair representation in test design. It includes diverse experts in test construction. You know that as a teachers, of course, we have to be fair. As have been mentioned in Al-Quran, Surah An-Nahl, ayah 90, that the meaning is, indeed, Allah commands justice, grace, as well as generosity to close relatives. He forbids indecency, weakness, and aggression. He instructs us to perhaps we will be mindful, so we can be fair to our students while we make an examination or a test for them. Well, we move to the last material that we will discuss today. Is about normal distribution. So, a normal distribution is a bell-shaped, symmetrical curve where most data cluster around the mean, with fewer scores toward the extremes. Many statistical tests such as t-test and ANOVA assume the data are normally distributed. For example, in ELT, suppose the TOEFL score of 100 students are assumed to follow a normal distribution. This assumption allows the teacher to predict that about 68% of students will score within one standard deviation above or below of the mean. And then, why is the normal distribution important? Of course, because it's statistical inference. Many tests, for example like t-test and ANOVA or regression, assume normality. And the second one, it's a real-world application. For example, Higgs IQ scores or measurement error often follow it. And the last one is central limit theorem or CLT. And then, what if data is normal? Of course, the first one is transformations. It includes log transform, square root, and also Box-Cox transformation. And the second one is non-parametric test. Usually, it uses Mann-Whitney U instead of t-test, and Kraskell-Wallis, I don't know to spell it well, it usually used in ANOVA. So, based on our discussion today, the materials that I've been present to you all, we know that these fundamental concepts are essential for conducting quantitative research in education, especially as an English language teacher. A sound grasp of these methods help educators or teachers and also researchers design tests that are valid, reliable, and fair. and to draw accurate conclusion to improve language learning outcome. So I will end my presentation today. Thank you for your attention and see you next time.